Today's lesson has been brought to you by Limitless Learning TT. For additional videos as well as more information on the services we offer, please visit www.limitlesslearningtt.com. You can also send us an email at limitlesslearningtt@gmail.com or give us a call at 868-354-3115. In this video, we will continue to provide solutions to the January 2014 CSEC Math Paper 2 examination. We continue our video at number 4. An answer sheet is provided for the question. The diagram below shows the graphs of 3 straight lines. We have y is equal to 2, y is equal to x, and y is equal to x plus 2. The first part of our questions asks us to state the correct equation for each of the following lines. Line 1, line 2, and line 3. Okay, so looking at the first equation, this y is equal to 2, we know that y is equal to 2 is usually a horizontal line, and the only horizontal line we have is line 3. So that means that line 3 must be equal to y is equal to 2. Okay, then we have 2 lines that look as though they're parallel. One passes through the origin, and the other one doesn't, right? So in order for line 2 to pass through the origin, it means that the point 0, 0 must be on that line, and therefore, when x is 0, y should also be 0. The only equation that's going to give us that when x is 0, y is 0 is going to be y is equal to x. So therefore, that means line 2 has to be y is equal to x, which means according to this elimination process, that line 1 has to be the line x plus 2, y is equal to x plus 2, and you can check that because one of the points on line 1 is the point 0, 2. So when x is 0, we get that y is equal to 0 plus 2. So that means that y is equal to x plus 2 corresponds to line 1. So this is our answer for line 1, 2, and 3. Part B says, show that the gradient of line 2 is 1. Remember, our line 2 is y is equal to x. Now you can do this 2 ways. You can look at line 2, which is y is equal to x, and you can remember that a linear equation is always of the form y is equal to ax plus b, where a represents the gradient and b represents the y-intercept. And if we're looking at our equation y is equal to x, it must be that a is equal to 1 and b is equal to 0. So therefore, if a is the gradient, that must mean that our gradient is 1. So that's the first way you can do this question. The second way that you can do this question is you can choose 2 points that lie on line 2. And you can do this by substituting any value. So for example, if y is equal to x, we can choose any value of x and find its corresponding value of y. So when x is equal to 0, y is equal to 0, because y is equal to x is the line we're talking about. And then when x is equal to 1, y is also equal to 1. So now we have 2 points on the line, 0, 0, and 1, 1. And we can use the gradient formula to show that the result is 1. So our gradient formula is y2 minus y1 divided by x2 minus x1 is going to give us our gradient. So we'll use y2 and x2 as this value, and we'll use y1 and x1 as this value. So we get that y2 minus y1 is 1 minus 0, and x2 minus x1 is 1 minus 0. So this leaves us with 1 divided by 1, which is 1. So you could have either done it this way, or you could have found the gradient. But either method is able to show you that the gradient of line 2 is 1. Part C asks us to shade the region which is described as y is greater than or equal to x plus 2. Well, we know that line 1 represents y is equal to x plus 2. So we're going to look at line 1, and we're going to pick a point that's on top here, and then we're going to check and see if that is in the region y is greater than or equal to x plus 2. Right? So let's say we pick the point, this point here, which is 0, 4. So we're using the point 0, 4. And we're going to substitute it into this inequality. So in our question, we have when x is equal to 0, y is 4. So y is 4, and that must be greater than or equal to our x value, which is 0 plus 2. Right? 4 is greater than 2. So therefore, we know that this point 0, 4 lies in the region where y is greater than x plus 2. So therefore, we're looking for the shaded region that is above the line L1. So our shaded region is going to be here. Anything that is lying above line 1. And just a quick refresher, when we're dealing with inequalities, whenever we're looking at y is greater than or equal to some line, we're looking for the area that is above that line. And whenever we're asked to find y is less than or equal to some line, it is the area that is below that line. And because in both of these cases we have greater than or equal to or less than or equal to, it also means that the line is part of the shaded region. So in our question, we also have to include the line as being part of our shaded region. If your question says y is strictly greater than or y is strictly less than, so that is strictly greater than or y is strictly less than, it means that we do not include the line as part of the shaded region. So part D asks us to write 3 inequalities that define the shaded region S. And S is shown in the diagram here. Now we're going to use the same information here, right? That whenever we are above the line, we're greater than or equal to. Whenever we are below the line, we're less than or equal to, and that's including the line. When we're looking at our shaded region, which is a triangle, we could already see that the shaded region is below line 3, right? It's not above line 3. So we already know we're below line 3. And line 3 represents y is equal to 2. So therefore, if we're less than line 3, it means that we are less than 2. So that means we are y is less than or equal to 2. And you can check that by choosing any point here, right? And substituting it just like we did in the previous part. We can also see that that shaded region is above our line 2. Okay, so this is our line 2. And we could see that region is above our line 2. It's on top of our line 2. So therefore, another inequality that we can use is y is greater than or equal to x. Okay, so let's show what area we have thus far. We have less than line 3, right? But we also have greater than line 2, right? So the area that belongs to both of those inequalities should be the area that has both lines and dots, and that is simply this area here. Oops. But this area that is double shaded does not coincide with our shaded triangle as yet. we have to put in one more inequality. And if we look at our y-axis, we realize that anything to the right of our y-axis, that is this area here, if we look at the area that has green x's as well as yellow lines as well as purple dots, it intersects with our shaded region. So our final inequality represents anything that's to the right of our y-axis, and our y-axis is represented by the line x is equal to 0, which is a vertical line. So therefore anything to the right of that line is going to be greater than or equal to. So we're looking at the line x greater than or equal to 0. So our shaded region will be the intersection of the yellow lines, the purple dots, and the green x's, which coincides with our shaded region. So therefore we have completed part D. And part E asks us to write the equation of the straight line which is perpendicular to L1 and passes through the origin. Okay, so we're going to look at line 1, right, because we're trying to find the line that's perpendicular to line 1. What do we know about perpendicular lines? We know that the product of the gradients of two perpendicular lines are equal to -1. And we know that linear equations are of the form y is equal to ax plus b, where a represents the gradient. So in this case, a must be equal to 1, because 1 is the assumed number right before x. So therefore, the gradient for the line y is equal to x plus 2 is 1. And we're going to call the gradient of our perpendicular line P. So therefore, if I multiply 1 by P, I am supposed to get -1. That's the rules of perpendicular lines. So 1 times P has to give me -1. So that means P is going to be -1 divided by 1, which is -1. So the gradient of my perpendicular line is -1. And now we know that in order to find the equation of a line, we need the gradient and we need a point on the line. Right? Now, we've already found our gradient of our perpendicular line. It's -1. And they did tell us a point on the line. They said that this perpendicular line passes through the origin. So therefore, 0, 0 must be a point on our perpendicular line. And now we want to find the equation of our perpendicular line. And we know that to find that equation, we use y minus y1 is equal to a times x minus x1, where a represents our gradient and and x1, y1 is our point. So a is equal to -1 and x1, x2 is 0, 0. Sorry, x1, y1 is 0, 0. So now we can substitute that and we get y minus 0 is equal to -1 times x minus 0. Y minus 0 is y. X minus 0 is x. So our equation of our perpendicular line is y is equal to -1 times x, or y is equal to -x. Let's move on to question 5. We will be omitting 5a since it's a construction question, We won't be doing that on this video, but we will proceed to 5 part B. 5b says that the diagram below, not drawn to scale, shows a block of metal in the shape of a prism. The cross section of the block is a trapezium Pqrs with parallel sides QR and PS. The perpendicular distance, and PQ is the perpendicular distance between the sides. And then they give you corresponding measurements. So PQ being 15, QR being 12, PS being 12, and ST being 3 centimeters. And the first part of part B asks us to calculate the area of the trapezium PQRS. So now we recall the area of a trapezium, which is equal to 1/2 the sum of the parallel sides multiplied by the perpendicular distance between the sides. So therefore area is going to be 1/2 times 6 plus 12, because that is our parallel sides, that represents QR and PS. And then our perpendicular distance is PQ, so that's multiplied by 15. And our answer is 135 square units. Square units because we're talking about area, and area is always in square units. Part 2 of 5b asks us, given that ST is equal to 3 centimeters, calculate the volume of the block of metal. Now remember, our block of metal is in the shape of a prism, so what we're looking to do is find the volume of a prism. So we recall the volume of a prism is A by H, where A is the area of the cross section multiplied by the perpendicular height. Well, they gave us the perpendicular height, that is ST, which is equal to 3 centimeters. And then the area of the cross section we would have found from the previous part, and that's 135. So therefore the volume of our prism is 135, which is the area of our cross section, or the area of our trapezium that we would have just found from part 1, multiplied by the perpendicular height that was given, which is 3 centimeters, and that works out to be 405. And since we're talking about volume, that means that it's in cubic units or centimeters cubed. Part 3 says a block of metal has a mass of 1.5 kilograms. Calculate in grams the mass of 1 cubic centimeter of metal. So we're given the mass of the block is 1.5 kilograms, which is the same thing as 1500 grams. And we're being asked to find the mass of 1 cubic centimeter of metal. Right now we know that our metal, the volume of our metal we would have just found is 405 cubic centimeters. And that corresponds to the mass of the block, which is 1500 grams. So therefore, 405 cubic centimeters is equivalent to 1500 grams. Basically, I'm saying that the volume of the prism is corresponding to the mass of the prism. So if 405 cubic centimeters corresponds to 1500 grams, that means that 1 cubic centimeter is going to correspond to 1500 divided by 405, which gives us 3.70, and that answer is in grams. So our final answer is 1 cubic centimeter is corresponds to 3.70 grams. Moving on to question 6e. In the figure below, not drawn to scale, the lines AQB and CRPD are parallel, and MQRN is a transversal. PQ is equal to PR, and angle QPR is equal to 28 degrees. So that's all shown in the diagram below. And the first 3 parts are calculate angles X, Y, and Z, and you're going to give reasons for each answer. Okay, so the first one that we want to find is angle X, which is here. And we can tell that those are alternate interior angles to QPR. which really means it's like in a Z. So that means that 28 degrees and x degrees must be equal. So therefore, x is equal to 28 degrees. And it is an alternate interior angle to angle QPR. Okay, the second one that we have to find is angle Y, which is this angle here. Right? What we're going to do first is look at the triangle QPR, which is an isosceles triangle. And if it's an isosceles triangle, that means that QP or PQ is equal to PR. That also means that this angle here and this angle here are both equal. And you can find those two angles, which are equal to each other, by saying 180 minus 28 degrees, because there are 180 degrees in a triangle. If we take away 28 degrees from 180, we're left with 152 degrees. And then we're going to divide that by 2 because angle PQR and angle QRP are going to be equal to each other. So 152 divided by 2 is going to give me 76 degrees. So that means that each one of these angles here are 76 degrees. And this one here is 76 degrees. Now, since angle Y lies on a straight line with angle PRQ, which is 76 degrees, that means that if I add Y plus 76 degrees, I should get 180 degrees because those angles are in a straight line. So therefore, Y is going to be equal to 180 degrees minus 76 degrees, which is 104 degrees. And your reason why is because angles in a straight line sum up to 180 degrees. And the last angle that we're finding is Z, which is this one here. And we know that this angle Z is going to be equal to this angle here. We would have just found that the angle that's within here is 76 degrees from the previous question. So therefore, angle Z is equal to 76 degrees plus angle X. And angle X is equal to 28 degrees from the first part of the question. So Z is equal to 76 plus 28 degrees, which is equal to 104 degrees. And again, the reason why is that angle Z and 76 plus X are vertical angles. So because they're vertical angles, they're equal to each other. So just to recap, X is 28 degrees, Y is 104 degrees, and Z is also 104 degrees. Okay, part 6b. The diagram below shows triangle JKL and its image J prime, K prime, L prime after a transformation. And part 1 asks us to state the coordinates of the vertex J. Right, so that's simply the coordinates of our point J, which is here. And we can see that that is at -4 and 1. So our coordinates will be -4, 1. Part 2 asks us to state the length of the side K prime, L prime of triangle GKL. So that is the length of this side here. And we can see that it's between 1, the x coordinate 1, and the x coordinate 3. So therefore the length is going to be 3 minus 1, which is 2. So the length of the side is 2 units. Part 3 says to describe fully a single transformation that maps triangle JKL onto triangle J prime, K prime, L prime. And we can see that it looks like a reflection in the line y is equal to x. The line y is equal to x looks like this. And we can see that each of the points and the image are equidistant from that line of reflection. So for example, K to this point is the same as K to this point, K prime to that point, and vice versa. Right, so it looks like it is a reflection in the line y is equal to x. So part 3, the transformation, a single transformation that maps our original triangle onto our image will be a reflection in the line y is equal to x. And the final part of our question says state the coordinates of triangle J double prime, K double prime, L double prime, and that is the image of our original triangle JKL under the translation by the vector 5, negative 3. So that means that we're going to move our original triangle, which is the solid triangle, 5 units to the right and 3 units down. Okay, so let's look at the point G. If we were to move the point G 5 units to the right, that will be 1, 2, 3, 4, 5. Will take us to this point. And then we want to move 3 units down. So that's 1, 2, 3. So this point right here will represent our J double prime. And that point is 1, negative 2. Right now we're going to do the same thing for the point K, which is this point here. We're going to move it 5 units to the right. That's 1, 2, 3, 4, 5. And then we're going to move it 3 units down. That's 1, 2, 3. So this point here represents K double prime. And that point is 4, negative 2. And we're going to do the same thing again, but this time we're going to do it for L. So L is this point here. We're going to move it 5 units to the right. That's 1, 2, 3, 4, 5. And then we're going to move it 3 units down. That's 1, 2, 3. So this point here represents our L double prime. And that point is 4, 0. So that means that the coordinates of our triangle J double prime, K double prime, L double prime is 1, negative 2, 4, negative 2, and 4, 0 respectively. We have just completed questions 4, 5, and 6 from the January 2014 Math CSEC Paper 2 examination. We will provide solutions to the remaining questions in subsequent videos. These videos, as well as additional information on the services that we offer, can be found at www.limitlesslearningtt.com. You can send us an email at limitlesslearningtt@gmail.com, or you can always give us a call at 868-354-3115.